Hello everyone, what we're doing is we've used trigonometry so far to figure out unknown side lengths. Now what we're doing is we're using trigonometry to find out unknown angles. Now the way to do this is if you look at the sine, cos and tan buttons on your calculator, you should see over the top of the buttons something like this: sine to the minus 1 above the sine button, tan to the minus 1 above the tan button, and cos to the minus 1 on the cos button. Now these will enable you, if you have the correct side lengths, to work out the unknown angle based upon the side lengths you have. Now in this case, if we have sine to the minus 1, what you should do is on your calculator press the shift button or the second button and then the sine button, and then put in this decimal point. Now after you've done that, what you should find is that it gives you 39.123. Now if you round that to two decimal places, as you should get 39.12. Now what this means is if you have a triangle like this with an unknown angle theta here, and this side is 1 and this side here is 0.631, what you've done is you've used the opposite of sine to figure out this unknown angle, and it is 39.12 degrees. Now what happens if you have one like this? Sine of theta is equal to 0.9. Now if you imagine a triangle here with an unknown angle here, and the opposite side is 0.9 and the hypotenuse is 1, this would be, well, sine is the opposite divided by the hypotenuse. Here's the opposite side. Here's the hypotenuse, that is 0.9 divided by 1. Now to figure out the unknown angle, we'll rewrite this as theta is equal to inverse sine of 0.9. Now if you work out sine of 0.9, it is 64.158, which rounds to about 64.16. Alright, what happens if we have this one here? We have cos of some angle is equal to 9 over 17. Now if we were to just draw a quick triangle, there's theta. Now cos is the adjacent divided by the hypotenuse, so that would be 9 and 7. So I don't want to work out any side length here, I want to work out this unknown angle. So it will be theta is equal to inverse cos of 9 divided by 17. Now when you put that into your calculator, you should find that it's equal to 58.034, which is approximately 58.03. Now again, we have inverse tan here, so on your calculator you'll probably find that inverse tan, or working out an angle, you'll need a little minus 1. Now if you do that, inverse tan of 3, so you press the second button on your calculator and then the tan button, and then you can put in 3. If you do that, you should find that inverse tan of 3 is equal to 71.565, which if you round to two decimal places should be 71.57. Let's take a look at another one using a triangle. Okay, what we want to do is to find theta for each of the following. So we've got two different triangles and two different angles. Alright, so let's have a think here. Well, here's our reference angle here. Straight across from this is our opposite side, and straight across from our right angle is the hypotenuse, and right next to our reference angle is the adjacent side. Okay, so let's see. We know the opposite side, we know the hypotenuse. Well, the ratio that involves the opposite and the hypotenuse is sine. So if we write down sine of theta is equal to the opposite divided by the hypotenuse, sine of theta is equal to 0. Now, sine of theta is equal to 17 divided by 28. Now, we need to get theta on its own. Now, the opposite of sine is inverse sine. So if we go inverse sine, 17 divided by 28, we'll find that theta will be equal to 37.383, which is approximately equal to 37.38. Okay, What about number 2 here? Well, here's our reference angle here, straight across from our reference angle is the opposite side, and right next to our reference angle is the adjacent side. And straight across from our right angle is the hypotenuse. So, let's see, we know the opposite side and we know the adjacent side, and we want to figure out this angle here. Well, if we were to rewrite it, we could say, well, that should be tan, because only tan is equal to the opposite over the adjacent. So if we say tan of theta is equal to the opposite side, which is 19, over the adjacent, which is 22. Now, to use tan to be able to figure out an unknown angle, we'll say theta is equal to inverse tan of 19 over 22. Now, if you do that, theta is equal to, and if you put that into your calculator, you should find it's equal to 40.815. Now we'll round this to just 2 decimal places, 40.82. Alrighty, we'll leave it there for today. Now all this is related to exercise 3H. So after you've watched this, have a bit of a go at some of the questions from 3H in your text. See what you come up with. If you have any questions, ask me in class.